In this video, we want to find these partial derivatives from this relation. What was this relation? If we remember, this was laws of cosines. A to the 2 equals to b to the 2 plus c to the 2 minus 2bc. The a, b, c are the lengths of the sides, and a at the end here is the angle a, so cosine a. From this relation, we want to find these partial derivatives by implicit differentiation. Because this is implicit relation, as you can see, a, b, c and are mixed together, we have implicit relation. So for finding these partial derivatives, we have to use implicit differentiation. Let me remind you a little about implicit differentiation. Suppose we have this simple relation. This is an implicit relation because x and y, as you can see, are combined together. Here, if you want to find dy over dx, or y prime basically, you are going to find derivative of x2, which is 2x. Then you are going to find derivative of y2, 2y. But because y is the function, you are going to multiply this by y prime or dy over dx. And derivative of the other side is 0. Then you solve this relation for dy over dx, and then you can find dy over dx. This was implicit relation, implicit differentiation. Now, let us solve this question. Here, what we have to do? We have to take derivative of the left side and the right side of this equation. For this one, we have to take derivative of both sides with respect to the variable a. What is the derivative of a to the 2 with respect to a? 2a. Derivative of b to the 2 and c to the 2 would be 0 because we take derivative with respect to variable a. So b and c are constant. Derivative of those terms are 0, 0 plus 0. We don't need to write 0, but basically we keep them here. Then we have negative 2bc. These are constant. Derivative of cosine a would be negative sine a. Attention, here a is the function, so we have to take derivative of this term. We are taking derivative of two things, variable a and the function. But when we take derivative of the function, we have to multiply it always by the partial derivative of the function with respect to the variable. So derivative of cosine a is not going to be only negative sine a. It's going to be negative sine a times by, because of the chain rule, times this by partial derivative of a with respect to a. Now we have to solve this relation for partial derivative of a, angle a, with respect to side a to find this. For that, let me simplify this relation. 2a equals negative times negative would be positive, so we have 2bc sine a times by partial a over a. If we solve this for partial derivative of a with respect to a, it would be a over bc sine a. And this is the answer for this partial derivative. Now let's find the other partial derivatives. Here the variable is b and the function is still a. So we take derivative of the left side and the right side with respect to b this time. Derivative of the left side, derivative of a to the 2 with respect to b is 0. Derivative of b to the 2 is 2b. Derivative of c to the 2 is 0 minus, this is, attention here, b and a. B is the variable and a is the function. So both of these have terms that we have to take derivative. Derivative of negative 2bc, we use product rule here. The derivative of negative 2bc would be negative 2c. So negative 2c times by cosine a. Then we keep the coefficient negative 2bc, multiply by derivative of cosine. Derivative of cosine is negative sine a. Don't forget to attach partial derivative of a with respect to b, of course. This time we want to find the partial derivative with respect to b. Now we have to solve this to find the answer. For that, we move these two terms to the other side and we divide by this coefficient. From that, we have partial derivative of a with respect to b equals to 2c cosine a minus 2b all over this coefficient, which is 2bc sine a. Factor 2 from the top and cancel 2 with the bottom, then you have c cosine A minus B over BC sine A. This is the partial derivative with respect to B. With a similar process, you can find the partial derivative of A with respect to C. And because of symmetry between B and C, can you guess without calculation what would be the partial derivative of A with respect to C? Attention, the partial derivative of A with respect to B is this. So what would be the partial derivative with respect to C? With respect to B, we have C cosine A. So with respect to C, we expect to get B cosine A minus C all over BC sine A. You can check by calculation that this would be the answer for partial derivative with respect to C.